Hello and welcome to this video. My name is Joshua Copeland, and in this video we're going to be talking about how I would teach the rainwater harvesting system in the construction technology classroom. We'll go through the learning objectives, the students' prior learning, and how I would teach an 80-minute lesson sequence. The learning objectives and success criteria involved in this 80-minute lesson include explaining how the rainwater harvesting system works by labelling the flow path and identifying the key parts, constructing and building a simple model of the rainwater harvesting system, and presenting the model clearly to the class by explaining how it works, naming the key parts in under 1 minute. For the lesson recap, the students will revise individually by going back over the hot and cold water system, household plumbing, the rainwater harvesting system, cistern plumbing, and the renewable energy sources such as solar and geothermal. They then pair up to discuss and compare their notes, helping each other fill in any gaps. This links with Montessori through independent learning and with Vygotsky through social constructivism and peer support. Following on, we will revise the weather cycle and link geography with construction technology. Students will work in groups to talk about the 4 stages of the weather cycle, beginning with the evaporation stage as water heats up and rises, then moving into condensation as the clouds form, following on to the precipitation stage as rain falls, and finally collection as the water gathers again in rivers and lakes. This reflects Frebel's idea of interconnected learning by linking subjects, along with Bandura through learning from peers, and connects with Bruner's spiral curriculum by revisiting and building on prior knowledge. Next, I will project the SolidWorks model of the rainwater harvesting system onto the board. This supports Gardner through visual, spatial and logical thinking, and links with Bandura through observational learning. I will use the model to zoom in on key areas and connect each one to real-life images, starting with the full plumbing layout and how it matches real rainwater systems. I will then focus on the tank and its internal pipework and show images of the tank being installed. After that, we will look at the boiler connections, including examples of domestic and industrial boilers, before finishing off with how the appliances are plumbed throughout the entire house. A SolidWorks model is particularly useful, especially for zooming into key areas and explaining them in detail. For instance, being able to zoom into the filter and seeing how it is plumbed, then going into the tank and seeing its internal plumbing, then going to the boiler and seeing how the water travels from the tank into the boiler, and then finally seeing how the water travels from the boiler into each of the household appliances through all of the plumbing network. Next, an animated PowerPoint depicting the flow of the water will be presented to the board, where students will be asked to predict where the water will flow next. First, we start off with the rainfall, which collects into the gutter and then flows down the downspout into the filter. The water then goes into the tank, and any excess water goes through the overflow. The water goes through the tank into the boiler, where it is heated, and then it goes from the boiler and circulates throughout the house to the household appliances. Water then goes to the outside appliances, where it can be used for gardening as well. Any excess water or wastewater will flow through the waste pipe. This aligns with Anne Meyer's UDL for representation and Benjamin Bloom for higher and lower order questioning. Everyone will have 30 minutes to make individual models. This links with Dewey's learning by doing, using lollipop sticks for the house, straws for the pipework, markers for labelling, and card for everyday household appliances. Students complete a 5-minute gallery walk to view each other's models, then 5 students give 1-minute presentations to the rest of the class. This reflects Dewey's experiential learning and Piaget's constructivism through explanation and reflection. Finally, to complete the lesson, students will complete a 10-minute bucket quiz and compete by answering questions on rainwater harvesting, hot and cold water systems, and the solar and geothermal energy. This links with Bloom through a mix of higher and lower order questions, and with Bruner through spiral curriculum by revisiting and strengthening prior learning. To conclude this video, I looked back on the students' previous learning, highlighted the resources I will use, outlined how I would teach an 80-minute lesson, and linked educational theory to classroom practice. Thank you very much for watching.